Today we are going to talk about how to solve quadratic equations by taking square roots. So to start out, let's talk about a few reminders when it comes to square roots. So we are going to actually be solving today for variables. So if I ask you x squared equals 4 to solve that, what you can do, the opposite of squaring something is square rooting it. So we can take the square root of 4. What we need to be careful of is that the square root of 4 actually has two answers. Normally, if I ask you what's the square root of 4, you're just going to say 2. But what else can I multiply by itself and get a positive 4? A negative 2. So my answer would actually be 2 and negative 2. So instead of having to write those answers separately, we're going to put a plus minus in front of it. So this right here just means that my answer is either a positive 2 or it's a negative 2, okay? And the same thing applies if it's not a perfect square. So if I say x squared equals 12, and we're trying to find x, if I take the square root of that positive number 12, then I'm going to get two answers after I simplify it, both positive 2 root 3 and negative 2 root 3. The square root of 0 is just 0. So I'm only going to get one solution if I'm ever taking the square root of 0. You don't need to put a plus minus in front because 0 is not positive or negative. Okay? If I'm taking the square root of a negative number, so let's say I'm looking at the square root of, we'll use negative 16 since that's in this example. What two numbers can you multiply together and get negative 16? They'd have to be different, so they're not the same number. So there are not any real solutions. Now, I'm going to reiterate this a lot more as we keep going, but the word real is actually very, very important because believe it or not, there are solutions to this, but they're imaginary numbers. So we're going to save that for Algebra 2, but there would be no real solutions if you were taking the square root of a negative. So we're going to look at two different scenarios that work when we are trying to solve by square roots. Both of the scenarios, b is equal to 0. So you have an x squared and you have a constant, but you don't have a variable in the problem with just x. Okay, so I would have these down in your notes so that we can refer back to them when we're doing our examples based on which case it looks like. So case 1, we're going to first distribute if you have any parentheses in the problem. Then you're going to move all your variables to one side, your constants to the other. So very, very similar to just solving a regular linear equation. You divide by the leading coefficient to get the variable by itself. But on this step, the difference between a linear equation is I might get to the end and have 2x squared equals 8. So if I divide by 2, now I have x squared equals 4. So in the previous units, we just had x equals 4, we were done. But now I need to get rid of that exponent. So the opposite of squaring something would be taking the square root, and then I just need to simplify. 4 happens to be a perfect square, and it's 2, so my answer is going to be positive or negative 2. We got to make sure that we don't forget that plus minus on the last step. So case 2, as you can see, looks a little bit different. Case 2 might look something like 7x minus 4 squared plus 3 equals 0. Okay, I'm not going to actually solve this because I just made that up, but you can still tell that you can solve by square roots in this problem because I have x squared. Okay, I've got that exponent of a 2, but I don't have a variable that just has the x attached to it. All right, common mistake here is that people want to distribute that 2. You cannot distribute the 2. So step 1 is going to be to move this value, whatever k is, to the other side. So I could subtract 3. Then I'm going to divide by a, which is the 7. Okay, then I'm going to take the square root because if I get to the end and I have x minus 4 squared equals, let's say 12, that's not the same as this example, but then to get rid of that 2, I can take the square root and this cancels out and then I can take the square root on that side. So what happens now is on the left, I'm just left with x minus 4 equals. Okay, so then I can move the 4 to the other side, and then if possible, simplify. All right, so first example is a scenario for case 1. So if you want to look back at your steps for case 1, first we're going to distribute if necessary. I don't have any parentheses, so I don't need to distribute anything. So I am going to start by just, again, treating this as if that 2 wasn't even there, just like a linear solving. So I can move the 6 to the other side. 84 plus 6 is 90. Bring down the 5x squared. Then I can divide by 5 to isolate my variable. So I get x squared equals 18. And then now I'm not done. So be careful that you don't circle this answer because I want what does x equal. Okay, so to get rid of my exponent, the opposite of squaring something is taking the square root. So that will cancel out that 2. And whatever you do to one side, you have to do to the other side. Okay, so now what I need to do is actually break down 18 and simplify this radical. So 18 breaks down into, we'll do 9 and 2, and then 3 and 3. So I have a pair of 3's, and I have a single 2. So couples go out, so the 3 is going to be in front, and singles stay in. So I'm going to have square root of 2 inside the radical. So x equals, and then again, don't forget that plus minus. You always are going to have 2 answers if you're taking the square root of a positive number. So my final answer is a positive 3 root 2 and a negative 3 root 2. And it's important that you know, you don't have to write your answers this way every time, but it's important that you know that this means I had 2 solutions. The first solution was a positive 3 root 2, and the second solution was a negative 3 root 2. So it is totally fine if you want to write it out like this, or just leave it with the plus minus in front. Example 2, this is going to be case 2. And you can tell because of where the exponent is located. So don't just go by, oh, there's parentheses, so it looks like case 2. My exponent is outside the parentheses. If your exponent is outside the parentheses, then I've got to go by this case because the other case, I'm allowed to distribute this 5 inside the parentheses. I cannot do that here because I have the exponent outside. Exponents would come first. Okay, so I need to first get rid of that 5, so I can do that by dividing by 5. And when you divide by 5, it cancels out on this side, so nothing is going to go with the x minus 7. So I can bring down x minus 7 squared equals 20 divided by 5 is 4. So now I want to get rid of my exponent. Again, don't distribute the 2. X minus 7 squared is actually the same thing as x minus 7 times x minus 7. And then we would FOIL. And this would become a much longer and unnecessary problem. Okay, so what I'm allowed to do at this step now is take the square root, and that gets rid of the 2, and whatever you do to one side, you do to the other side. So now I can just bring down x minus 7, and then the square root of 4, again, be very careful with this step. It is 2, but it is both a positive and a negative 2. All right, so now my last step for solving would just be to move the 7 to the other side. So what I actually end up with here is a positive 7 plus or minus 2. Now, I can simplify this because these are all whole numbers. So what this means is that my first answer is positive 7 plus 2, which is 9. And then a common mistake for people to do is go, oh, okay, so my answer is plus or minus 9. Be very careful. This second one means x equals positive 7 minus 2 because it was a negative 2. So 7 minus 2 is 5. So your 2 answers to this problem are x equals 9 and x equals 5. Example 3 is another case 2 scenario. Again, the way that you can tell is that this exponent is outside the parentheses. So step 1 for solving, I need to move k, which is the 8, to the other side. So minus 8 minus 8. So that's 13. And then we can bring down the x plus 3 squared. Okay, I don't have a coefficient in front. I don't have an a to divide by. So now to get rid of that exponent, I can take the square root of both sides. So over here, I'm just left with x plus 3. And you can drop the parentheses here because there's, again, no number in front that needs to be distributed and your exponent is gone. So for the square root of 13, we would want to break this down now and see if we can simplify it. But 13 doesn't break down at all. So this is going to stay the square root of 13. But again, don't forget it's positive negative root 13. So now my final step is to move the 3. Now this is very different from the last problem. I can't do 13 minus 3 because they're not the same radical. I don't have the same number underneath. I can't actually combine a whole number with a square root. So I'm going to write this as negative 3 and then plus or minus the square root of 13, and that is my final answer. Example 4 looks a lot like case 2, but this is actually case 1. Okay, and I think the reason that people get confused and it looks like case 2 is because we have parentheses. The difference here is that my exponent is inside the parentheses. Okay, so if the exponent is attached to your variable and it's not outside the parentheses, we're going to treat this just like case 1. So for the first step, we are going to distribute. You could, if you would like, divide by 2, just like you do in case 2. You're actually going to get the exact same answer. I think most people, though, tend to distribute, so I'm going to do that first. So we would get 4x squared minus 2 equals negative 34. Okay, and now I solve it just like I would a linear equation. So I'm going to add 2 to this side. Careful with your signs. Opposite signs subtract. So negative 34 plus 2 is negative 32. And then on this side, I can bring down the 4x squared. So now we divide by 4. X squared equals negative 8. And now to get rid of that exponent, I can take the square root of both sides. Now, does anyone notice anything about this problem? We are trying to take the square root of a negative. That is not possible in Algebra 1. We don't have any real solutions. So this is actually going to be no real solutions. And it is very important that you are writing the word real in your answer because there are solutions, just not any real number values. All right, example 5 has a lot going on here. I've got parentheses on both sides, but my exponents are inside of the parentheses. So that makes this just like case 1, and I can solve this very similar to a regular linear equation. For those of you who prefer dividing on the first step and you're thinking, I want to divide by 4, I can't do that over here because this number is not divisible by 4. So on this one, you can't really avoid having to distribute first. So I'm going to distribute the 4 on this side, and I'm going to distribute the 3 on the right-hand side. So we get 12x squared minus 24 equals 6x squared minus 24. So now I can start moving my variables to the left, my constants to the right. The order that you move them in doesn't matter. So we get 6x squared minus 24 equals negative 24. Add 24 to both sides. And don't panic at this step, okay? Negative 24 plus 24 is 0. So we get 6x squared equals 0. But we can keep going. Divide by 6. 0 divided by 6 is 0. And then if I take the square root, The square root of 0 is just 0. And again, we don't need to put a plus minus in front because it's not positive or negative. So x equals 0 is my final answer. All right, example 6. Notice your exponent is outside the parentheses, so that makes this a case 2. That means I cannot distribute the 6. Now, I also don't want to divide by 6 first, so make sure you're looking back at your steps. The first step is to move this value at the end to the other side. So I want to move 117 to the right-hand side. So we're going to bring down the left, 6x plus 1 squared equals, and then 75 plus 117 is 192. And then divide both sides by 6. Again, you cannot distribute the 6 because of where the exponent is. So I'm going to bring down x plus 1 squared, and then 192 divided by 6 is 32. So now I'm at the stage where to get rid of this exponent, I can take the square root, and then I am going to need to actually break down 32 now to simplify it. So I can break that down into 8 and 4, and then 8 is 2 and 4. So that gives me a pair of 4s and a single 2. So I'm going to bring this over to the side over here. So now we have x plus 1 equals, couples go out, don't forget your plus minus, so 4 was my pair, and singles stay in. So I have a single 2 inside. So now my last step, subtract 1. So remember, these are not like terms here. I cannot combine a whole number with a radical. Okay, the number underneath the radical would have to be the same. So in the event that this happens, we're going to put our constant first, so negative 1 plus or minus 4 root 2. And this is my final answer.